Hello, Miss Dora. This is Brandon, and we will be going through the entire ETL process in this video. So we will start by looking at how we can create the Oltp database. So let's have a look. So our database is created this way. Of course, first, before creating the tables, we must first create the database, which is this. So as you can see, I have already created here. So I will just be executing all these commands again. Okay, so first we create the database. So we create a database. I'm going to name mine bi underscore CA1 underscore OLTP. So this is the database. As you can see, it's successfully created. So, and it should automatically change here. So now we will create the tables in the database. So the tables in the database actually has to be created in a certain order due to some of the tables having functional dependencies, or otherwise known as foreign key. As you can see over here, there are some foreign keys, and so it makes it difficult to create everything at once, and therefore it has to be created in a certain order. So as you can see, offices here have no functional dependencies or foreign keys, so it's actually quite safe to create. So I executed it and it works fine. So next we'll move on to employees, which has a foreign key which comes from officers. So as we know, we already created officers, so employees should be safe to create. So I execute and it's fine. So basically this goes on for the rest of the tables. So those without functional dependencies or foreign keys should be fairly easy to create and shouldn't have a problem. And those with must make sure that those tables have already been created. So for example, product lines is already created. And customers. So yeah, we're gonna move on and just execute everything. Payments and orders and order details. Alright, so that's it for the OLTP. So now we created all the tables, but they're all blank. So now we're gonna have to try and look at how we can actually fill it with data. So, okay, we're going to have a look over here where I have my insert data for OLTP. You can just open that. Okay, so as you know, some of our tables have functional dependencies, also known as foreign keys. So that also means that when we insert data, we have to insert it in a certain order. So as we know, we created officers first. So officers is also going to be the first to be inserted, as it has no foreign keys, which shows that it updated into 7 rows, perfectly fine. Next, we'll move on to the employees table. So we can just scroll down, okay, and execute. So basically, as long as it is in a certain order, and you make sure that the order is fine, those things should execute perfectly fine. So now for products table, this will be a bit tricky because of the JSON. So basically what we need to do for this is to, okay, so from the link, we can actually go to our files, the HT docs. This is where we are supposed to save the folder, the file, which I have named as etl products.php. So this file will help us actually to sort of extract the data and use the data and get it in. So, alright, this is what my file looks like. So for the server name, we're supposed to change to the server, our own server name. So mine is this SQL DBIT and B151, basically SQL Express. Yeah. So this is my server name. And what else do we have to look at? Okay. So we have to look at this. We have to change this to our own link. the file get contents. So this is the link already. Basically, it's that link that we saw over here in the SQL. So yeah, that's the link. And then we have to change these also, the for each. So basically, we have to change it to however we want to insert into the products. So product code, product name, product line, scale, vendor, etc., etc. So these are the values. So here it is. And once everything is fine, once everything is done, all the edited has been edited, we can actually move over to execute this in the browser. So in a browser, all we have to do is key in localhost / bi, which is the name of my folder where it's stored. Just enter that. So wherever your thing is stored, you just have to find it. Oh, hold on, let me just fix that. Okay, I forgot to mention that we also need to have our XAMPP on. So now that our XAMPP is on, up and running, we can actually try again. So we go localhost / whatever folder you have it in. Mine is called bi, and you come to this directory. So in this directory, you can see the files right here, the etl products.php. So with that, we can just click on that, and the records are created. This shows that it's successful. So from here, we can move on to the actual usage of the codes. Alright, so now we see records created. We can actually move over into the SQL. So yeah, actually let me check, just to make sure. Yeah, to see that it's actually up and in products. So it should be working now. Yep, as you can see right here, everything is in. So it shows that it's done successfully. So now we can move on to the customers table. So the customers table is a different method. It's actually using the bulk insert. So for the bulk insert, our data rather, is received in a customers.csv, which is a form of the Excel. So we have to go through some cleaning up. So let me just show you what it's like. So in Excel, sorry. Okay, so this is what it looks like after cleaning up. So basically, we had to remove some commas. So because what it looks like in plain text is this. So this is what it looks like. So for example, 54 Rue Royale, there used to be an extra comma right here, if you can see. I'm going to highlight it. So basically what it does is that every comma is like a separator for the columns, I would say. So 103 is one in one column, and then the comma separates this, so they move on to the next one. Atelier Graphique, and then comma, so it separates, and then Schmidt, and then Karine, and then these numbers, and then this address. But the thing is that this address has a comma in it, so it thinks that this is one column, the 54, and Rue Royale is another. So what we did for the cleanup was to remove all these commas, and also some of them were listed as null. So if I'm not wrong, one of them was here, but we have to replace them with blanks. So after a lot of cleaning up, all of these became accepted into the SQL server. Yes. So after cleaning up, these are what some of them look like. So yes, this is the data. So we can go right to here, and we use our data. Okay, sorry about that. I was cut off from the video because there is a time limit. So, alright, let me just go through this really quickly. So where I stopped was somewhere here, if I'm not wrong. So after that cleanup of all the data in the CSV, we can just execute this. I've already executed it in the previous video. So basically, execute and it will show that it's successful. So field terminator is the comma and the \n is the row terminator. So basically, nothing much too fancy here. So we go on to the inserting of the rest. The rest is all data that is already kept here. So we just insert. I have already inserted all of them. So so these have a certain order, of course, because some of them have foreign keys. So they have to be inserted in this way because if not, there will be errors and they will not allow you to insert. Yeah, functional dependencies. So the order goes like this: table, the payments table, the orders table, order details table, and that should be it. Yes, so all of these are inserted in this order. So let me just run through one time again. Offices table, followed by employees table, and product lines table, and the products table from the JSON, and the customers table from the bulk insert from the CSV file, and the payments table, orders table, and order details table. So that is it for the OLTP inserting of data. So now I would like to move on to the data warehouse in the creating of the core dimensions. So basically, first of all, we have to create the new database for the data warehouse. So we'll just right click on database, create new database. So I'd like to call mine again bi_ca1 underscore. So this is data warehouse. Let's call it dw data warehouse. Right. So we have created the data warehouse. As you can see, it's right over here. Sorry, it's actually right over here. And it should automatically switch, except it didn't. Alright, so we switch over to the data warehouse. So now in the data warehouse database, we can now create what is the auto table here? Okay, well, we can now create the dimensions. So we can start with the customer dimension. No problems here. And then we can move on to the, I don't think there should be, okay, never mind, forget that. Must have forgotten to delete that. So we can move on to the create product dimensions. So we execute. It should be fine because there's no foreign keys on this. So yes. Employee. So let's just check back and see that we have created customer, employee, and product. So we can go on to office. And we go on to time. So time is this long one here. It's pretty standard. Okay, so let me just start from here and go up to create time, and that's done. So if we do a refresh on the tables, we'll find that time, product, office, employee, and customer. So those 5 have been created. So and then the last one is of course sales facts, the one in the center. So create this. Okay, so we can create this. Yeah. Okay, and then for the sales facts, of course, because it's linked to everything else that's of the core in the center, we have to do these following steps, which is the alter table and to add foreign key. And this is done successfully. So now that we have all our dimensions created and the facts table created, we can just check back one last time. Time dimension, sales fact, product dimension, office dimension, employee dimension, customer dimension for a total of 6. So now we will move on to the Etl process. Yes, Etl process. So okay, well, since time is in a sense independent, we will start with that. We will start with time. So time, we will have to declare the start and the end date. So we started with 2003, ended on 2006 for ease of convenience and just to be safe, because I know the assignment says it's around 2003 to 2005. So we just extend it and make it safer. So now it's 2006. Okay, so this is all standard declare values. So basically that's the only thing we have to do. Let me just check. Okay, so we can just execute this one time from the top. And there's a incorrect syntax. Sorry, let me just fix it. Okay, somehow it seems that there was a slight bug. I didn't change anything, I just click execute and it seems like everything has been added in. So maybe it's just my computer acting out on that part. Alright, so let us move on. So basically this is the only thing we set, the start and the end. Everything else is in a sense a standard. So all the rows has been affected, as you can see, many rows. So let's just move on. So that now we have to create the time. We can move on to create the core dimension tables, to fill the core dimension tables. So Etl data to dimension tables. So yeah, so as you can see, oh yeah, and I forgot to mention, most of these have no foreign keys because in a data warehouse, the tables are usually denormalized data. Yes, so basically no denormalized key. So basically there is no how would I put it? No order in a sense to have to create them in. Yeah, but I'll still do it one by one here. So the delete from and insert. So usually the from is to make sure that there's nothing inside, and then so that we can insert from into a fresh one. So 0 rows affected, 122 rows affected. It shows there was nothing in the first place, and that now there is 122 rows in it. So customer dimensions, and then we just follow accordingly. So alright, 110 rows, 23 rows, and last but not least, 7 rows. So all of these has been filled properly and without any error. Okay. Alright, so we move on to the sales facts table. Oh, I also like to mention that the time dimension for the data warehouse is actually really extremely useful because this helps us see the in a sense it helps add an element of time to our data warehouse, so we can see monthly reports, yearly reports. We can use these time frames to sort of have a idea of the granularity and the usage of the drill up and drill down functions to see how much data we want to see in one shot, or do you want to see the whole cluster, or do you want to go down to the days and the months and the weeks where maybe we have made more money or maybe we've lost money and stuff like that. So it's really useful for the time dimension to be in a data warehouse. So as we said, we're moving on to the fact table. So this is the fact table. So as usual, we delete from sales facts just to make sure 0 rows affected. So there's nothing in it at first. So we go into insert. So the sales fact table is of course definitely very different. It's much longer. So this is how we are going to insert into the sales facts table. So okay, as you can see, insert into all the way to here. So all these are for the sales facts table. Alright, so as you can see, basically, okay, so as you can see, it's inserting into these specific columns and stuff. So as you can see, select replace O dot order date. So this format is relatively familiar to us. So we know O dot order date means the O. This order date refers to the O, which is also short for the orders. So as you can see, this aligns perfectly. So order date goes to time K, employee number goes to employee key, and so on and so forth. So they all align. So, and they come all from these tables from here. So all like that. And if we just execute everything, it should work fine. So 2,996 rows affected, as you can see. It looks messy, yes. It looks complicated, yes. But the format is more or less the same. So if we do just a check right now, we can see that our So as you can see, all the data is all in. So yeah, you can just execute. I want to show you everything is fine. It's all good. So yes, okay. Now we will go and check. So this is the end of the ETL, but we still have to check. So I have some tests that could help show. So these are the questions I actually use for um, the pivot chart, pivot table, but they work perfectly as checkers for this. So it shows top 5. It shows it's all working. Order by is good. Just to check another one, we can have maybe this one. And it shows the city, the sales. Yeah, looks like everything is working fine in D1. So that would be the end of the ETL process. So now that that is the end, we can just conclude this entire thing. So basically, what we have seen so far is the update, the creation of the Oltp and the data warehouses, and the uploading of data into the Oltp and the ETL into the data warehouse. So the main difference, as some of us already know, is that the data warehouse is a historical. Okay, let me rephrase that. So the Oltp is a place where data is constantly updating. It's used for things like cashiers, ATM machines. They are always updating their info. Whereas data warehouse, as the name implies, just keeps collecting data historically and kind of historically marks them by their dates and stuff. So basically, it just keeps collecting data and it shows the pattern and trend of data. So whereas Oltp is different from that. So just want to kind of explain the difference and to see the difference between them also. Okay, so the operational database and data warehouse in terms of database design. So the design, basically, the data warehouse is designed in a star schema. Why is it a star schema? Because simply it looks like a star. Yeah. If you want like to see, this is what it looks like. So this is a sample of what it looks like. This is a old sample, but this is the new sample of what it looks like. So basically, as you can see, it kind of looks like a star in a sense. Basically, this is what it is. Sales swag in the center and the surrounding are dimensions. So we chose to use a star schema for the data warehouse. Alright, so this would be the end of the video. I hoped that I was clear enough, and I hope you enjoyed it.